Thomas C. Cannon, Jr., born 1943, couldn't find any sources on whether he's alive or dead. African-American communications engineer. The fiber optic cables that today we take for granted could not function properly without a thorough understanding of their structure. Thomas C. Cannon, Jr. has provided much of the research that makes fiber optic technology possible. He helped design, plan, and install the first commercial fiber optic system in the United States. He was born in Houston, Texas, on January 8, 1943, to Thomas C. Cannon Sr. and Lillian Bland Cannon. As a boy, young Thomas was interested in building model airplanes, which presaged his future career. He attended Purdue University in Indiana, receiving his bachelor's degree in aeronautical engineering in 1964. He stayed on at Purdue for his master's, which he received in 1966, and for his PhD, which he was awarded in 1970. He was named a Stanford Sloan Fellow in 1987 and received a master's in management science in 1988. After leaving Purdue, Cannon joined the Federal Systems Division of Bell Labs, formerly part of AT&T, now part of Lucent Technologies in Whippany, New Jersey. He helped design a cable system that would help detect submarine activity. One of his tasks was to ensure that the cables, which were being made with the synthetic material Kevlar instead of steel, would be able to withstand the same stresses as those made with steel. His study of cable design principles for this project was good preparation for his next assignment at Bell Labs' Atlanta facilities in 1974. Bell researchers were experimenting with fiber optics. A key problem that they faced was determining how much stress would be placed on the fibers, which were made of glass, during cable manufacture and installation. Without this information, the cables would function poorly or break outright. Cannon developed the mathematical equations necessary to predict the effects of physical force on the fibers. These equations allowed manufacturers to design cables that will be manufactured and installed without creating harmful stresses on the fibers. Another problem that Cannon helped solve was figuring out how to connect the hair-thin fibers without losing light energy at their junction. Cannon and his co-inventors came up with a solution, the S.T.E connector, which was the most widely manufactured optical connector in the world. The first practical application of this was the experimental fiber optic light wave system that was installed under the streets of Chicago in 1976. Cannon supervised the group that designed the cable terminators and optical connectors, and he actually went down manholes and did some of the splicing himself. On a different level, Cannon and his group also developed the tactical fiber optic cable, developed the Tactical Fiber Optic Cable, TOFC, which was the first optical connector certified by the military. The TOFC was used in Operation Desert Storm during the Gulf War to transmit firing signals to Patriot missiles. Between 1989 to 1992, Cannon was on special assignment in Sandia National Laboratories. At Sandia, Cannon helped devise ways to improve the reliability and safety of nuclear devices by helping develop more effective means of arming nuclear devices. He also helped create a program that identified and evaluated methods for making hazardous sites more environmentally safe. More recently, Cannon has led the development of new communication products and identifying potential markets for them. He has also been active in mentoring programs, particularly for young minority professionals, both at Bell Labs and at several universities including Purdue, the University of Michigan, and the Massachusetts Institute of Technology, MIT. He is the author of Survival Routines for Professionals Moving Toward Corporate Success, 1988. Outside of work, Cannon coaches community youth basketball and baseball teams. He was selected as a torchbearer in the 1984 Olympics. Cannon married the former Joyce Elaine Scott in 1967. The couple has 4 sons. Citations and sources of this audio are in the description.